It is very exciting.
Hello and welcome back to Reconstructing the World, the best YouTube channel in the world in regards to building sustainable. And it would be funny if it was only me, but it's not only me. So let me introduce to you the most sustainable architect in the world, Anders Lennager.
Good to see you.
Oh, welcome back.
We're going to talk about facades today.
Facades. Yeah. What is facades? Facade.
The facade.
There's a facade there.
The facade is everywhere.
Look at that facade.
Yeah.
That you didn't make that, right?
No, that's not very good.
Because then this YouTube channel is off.
Yeah. Then we're fired.
Yeah. Okay, so you have a facade over there. That is classic urban facade, city structure. Then of course we have the old facade of the urban buildings.
And then the old, very classical carré facade.
Oh yeah.
And then kind of very modern new carré facade and more office building. And one of the biggest problems with many of these facades is that they're really using a lot of resources.
Okay.
They are usually made out of CO2 intensive materials.
Aluminium,
bricks,
glass,
bricks,
Okay.
concrete, and even worse, composites.
Composites is the worst thing, right?
The worst thing is when we talk sustainability is when we mix materials together and we can't take them apart. So for sure it's difficult to recycle them.
Yeah.
We know when they need to be recycled.
Yeah.
And also when you make the materials, they're often made with a lot of chemistry and a lot of energy.
It's like, imagine you take a cup of coffee and some milk, pour it together, and then afterwards say, let's split it up.
Yes, I only like the
Fucking hard.
only the latte, not the coffee.
So either black coffee or the oat milk,
Yeah.
of course. That's most sustainable.
Yeah.
Okay, so you are thinking for this, the building of træ, you are of course thinking, and you always do, thinking in new ways of building a facade, right?
Yeah.
And what is your thinking? What is it that, if you don't want to use traditional materials as over there, it's some maybe what?
In the towers.
Steel or?
Steel, even brass and cotton steel that's new.
Yeah.
All kinds of metals, or as I said, composites, which is the higher the building is, the more complex materials you often use because you don't want to have any maintenance.
Okay.
So the impact on materials from high rises around the world is often really intense.
And we will go back to the material room and talk about that also.
Yeah.
You want to rethink facades entirely, right?
Yeah.
Because I see tons of your building. We can show a couple of them here. You are actually pretty well known within architecture, circles?
Yeah.
For rethinking facades.
Yeah.
Is that correct?
Yeah. And the buildings itself, but today we're talking about the facades, and I think what
So
we have
keep
to,
on track.
We have to remember, to keep on track, but also to remember that basically all building facades could be made out of waste materials.
Okay.
And one of the paradigms for this is that form starts to follow availability. That's a paradigm shift in how we design buildings and how the facade starts to look. We had to look at the materials that we have in hand and then start to shape the building from what we have.
Okay, let's do a quick detour because that's what that's the time where I discovered Anders, was that when he did this one. This was like old 70s buildings, right?
Yeah.
I remember this is that old 70 buildings in red tile. Is it called red tile?
Red tile, yeah.
Okay.
And brick.
But they're shit bricks, right? Not made of shit, but shitty made.
The problem is from the mid-60s and until today is that the seam here, the mortar, is made out of concrete. It's so strong that it's stronger than the stone.
So it breaks up the stone.
So you can't recycle bricks, which you have been able to recycle the past 300-400 years, as the monks did it. And now we put it so well together that you can recycle it. So we thought, what if you can cut like a whole square meter out and recycle that? The idea here is to find new innovations, and then we've been building big buildings with old buildings that was cut down with a cutter and moved and then used as large bricks to build the whole facade.
That's
one idea.
Brilliant. But today we need to talk about the facades for træ.
Yes.
And you discovered a new material, right?
Yes.
Where is it?
The new material, there's some of it right over here. But there is another mock-up. a test we did.
Like, this is a mock-up.
That's a
Mock-up is, fuck, you know what a mock-up is. But this is a mock-up. So it's like a test of what you were thinking, right?
Often we see problems where we have discarded materials, and one of the materials that are the lowest in the hierarchy of beauty is these trapeze and sinus steel and aluminum sheets.
And you see them on farmhouses,
everywhere,
barns, all over the countryside, where you need quick building materials, cheap, up in a fast way.
Yes.
Tons of it.
Yes.
It looks super crappy.
Super crappy. Yeah. But the facades or these steel sheets, they and steel in general is a huge challenge because they are usually on buildings that lives very short.
Yeah.
So they become waste. And when you have steel waste, you need to find a way to recycle it.
Yeah.
But you use so much energy to recast the steel.
Yeah. As a recast, meaning melting it down.
Melting it down.
Taking it up so you can make beams and...
So you can make something else. Okay. So the best thing you could do ever was to find a way to direct reuse the material.
One to one.
Like
with very little energy, just reuse it.
Yes.
And I can now reveal that happens something crazy on this YouTube channel is that Linear, the most sustainable architect in the world, actually got a handle on his door. And just a fun fact, this is made out from what?
Radiators and all the piping for the radiators here in the office that we didn't need to use.
Most sustainable architect in the world.
Now we go into nerd attack. Of course, it's fun just to drive over the sheets.
We haven't got to that part.
No, but it's coming. But if we have to go into nerd attack here, we need to have some data. So what is our client's biggest fear when you want to recycle?
Spiders.
Spiders and corrosion.
Oh.
And there is a corrosion classification, just as you know classifications of danger of spiders.
Yeah.
It's basically the same. So in this case, it's corrosion. Corrosion is when steel in the mix with air, moisture, salt, and other chemistry starts to deteriorate and disappear.
And become rust.
Rusts.
Which sparkle into the
corrosion.
Universe.
Yes. Okay. What we found out was that one of the reasons why we're not recycling this steel and aluminum is because there's something called corrosion classes. And these classes are defined in the 70s because we had a lot of pollution from cars in there because they were polluting.
Oh, because there were lead in the...
Lead and NOxes and everything that came out of the cars. And we had a lot more industrial factories close to the cities. So the cars were, corroding and everything were corroding. And because of that, there were standards. But what we found out was that when we look at salinity, which is how much salt there's in the air, it's not that high when you look at Sjælland and Mid-Jutland.
And we are here.
And we're here, yeah, exactly. And also when we looked at how much chemistry or sulfur on us, that's not a problem anymore either.
Because there are no dragons.
There's no dragons, there's no factories close to the cities, as I said. Which means that now we can control, or at least we know that the corrosion of these sheets are going really slow.
Okay.
So we tested the metal and we found out that the corrosion, we took tests like these small pieces, and then we went to we call it Teknologisk Institut, which is a technological institute for testing materials, and we put it into a test chamber.
With the dragon.
With a lot of dragons, sulfur, salt, and bad weather.
Okay.
And we could see that it could last at least 40 years if we knew that the dimension, the thicknesses of the metal was right.
Yeah.
So by testing that, a little bit of energy put through the sheet to figure out how the strong and the quality of the steel is. We found out that we could recycle these materials. So even though they've been on a building, these ones that we were driving over or going to drive over.
Don't say it.
I'm not used to this.
No,
I'm spoiling it.
No. So
if you were to do something about these things,
If you were going to somehow make some funny thing with an electrical car and those, yes, that would then
Unless
be...
you're spoiling the whole thing.
Shit, we're
Don't
really
say
bad.
it.
We're really bad at this. We're both really bad at this.
Well, where was the talk?
We went for the corrosion, and you found out that these steel plates, because you put it into a tiny room with a dragon and some weather and stuff, you found out that there was no problem in
Yes. And the thing is that then we found out that these sheets that's been on a building for 20, 30, 40 years, they had at least 40 to 50 years of lifespan left.
And that's enough?
So that's enough.
40 years, you said?
No, at least. So the fact is that these sheets are just as good as new. But today we are remelting and recasting the whole thing instead of direct reusing it, so as we saw on the life cycle.
So, to make it short, you found out through testing, your own testing again, your own LCAs, your own, technological institute trials. You found out this is more than ready to be made to a facade material.
Yes.
Great.
And then we found someone who wanted to play with us. Because it's so important when you want to recycle, upcycle waste as a product, you find someone who wants to work with you. And here we found a partner. Yeah. And because they saw the quality of this waste material and this documentation, they said, yes, we're going to give you at least 10 years of guarantee on the material, which means that you can build with it.
Is a partner is like a building material partner?
That's a big factory that works with this. So now it's ready to be scaled, hopefully. Not only for this building, but for other buildings as well. So what you're
again saying here, as in the episode with the windmill wings,
yes,
this is ready to scale, right?
Yes, and you can just recycle all steel that you see, but test it and find this data.
Yeah, but you're not happy with the look, so let's go back to...
Do you have an idea about what we could do with them?
I have an idea.
So you did this?
Yes.
But you didn't want it to look like that, right?
No, we found out that maybe these facades would be a little bit monotone, a little bit boring if it was on 5,000 square meters. So we said, what could we do with these sinus sheets or trapeze sheets to make them look different?
And what you came up with?
We came up with a super easy solution. What if we just drive over the sheets with an electric car?
Okay. And imagine what we are going to do now then.
Welcome to the dramatization of Anders Lena, most sustainable architect in the world, getting the idea of flattening a steel panel for a facade on træ building, starting now.
What are we doing?
We're going to see if we can make kind of a new facade out of this trapeze sheet.
So this is going to be a new facade.
This is how we start testing it. So we need to drive over it with something really heavy. Do you have a car?
It's a reconstruction.
We're reconstructing.
Do you have a car?
I have one.
Well, is it electrical? We only use electrical cars in the production.
I have an electrical car.
I have one as well.
Let's do best out of 3. Which one? This is actually how Anders got the idea of
this. Yes.
I'm gonna go to my electrical car.
Lucky bastard.
And you can guide me, Anders.
Okay. The idea is that we want to change the shape of this sheet to make it just different. And so what we want to do is to make it as flat as possible. So this was the first start of how we could do it. So let's see if we can make it flat by driving over it a couple of times. You just hit it with your front wheel. It has the exact same shape.
It's extremely disappointing. So the steel plate didn't work for the reconstructing of flattening, right? So what have we done now to exemplify this?
We've changed to a different material that we're also going to recycle, which is aluminum sheet.
Oh, so this is not even being, that idea is not even being used in a building already?
No.
So this has never been used?
No.
So this is not reconstructing anymore. This is real time,
one-to-one.
Real R&D. Fucking love it.
starts to
Yes.
deform, right?
Now,
It starts to change a little bit, right?
you have a very low.
Well
Thank
done.
you for the. And that ends.
But we're going to show
We're
now
going to
how
show
it's
a
going
total
to
flatten,
look, because
but-
of course it's not
Yeah,
going to be
no.
made like this. Let's go and check it
Let's
out.
go to the material room and talk
Yes.
about the rest.
Yes, let's go.
It has small dent. Yes, and after a very successful reconstructing of Anders getting the idea of flattening, I succeeded flattening it with my car. And it nearly looks like yours, right?
It's this is how it has to look. I mean, I took my car. It was a little bit more heavy. Also, an electrical vehicle, right? So this was the real test, and this showed us that maybe by kind of putting pressure on the trapeze sheet, it starts to create these beautiful magical surfaces. What about yours? How does that look?
I have 0 beautiful surfaces on mine. But of course, this is about the most sustainable architect in the world, Anders Lindager, and not about me. So let's continue.
It's okay, Anders.
Yeah, let's continue.
You're good at so many other things. This was what actually showed us that we could change it, right? And so we said, okay, could we go even further? So I'm sorry about all this noise.
No, but very quickly, it looks like this from the start, right?
Standard trapeze sheet, as you see it everywhere.
And this has been on a building for...
It's been on a building for at least 20 years. So it looks like this on one side and a bit more fresh on the other side.
Okay.
But then you still have holes for the screws and mounting.
This could be on a production of pork meat or whatever, like a barn.
A barn, industrial building. It could be of so many different buildings.
Okay.
Usually they don't live that long, the buildings. Sorry about the noise.
Yeah. So you flatten it like this, found out, hey, it's not a sustainable way of flattening things.
Yes. And then you ask someone that actually has the real thing that can put this through a machine that flattens it down with these big circular heavy rolls. So it rolls through this and it becomes this beautiful flat surface. But you can still see the lines in it, which means that when this is mounted next to the trapeze sheet that we had before here, then you start to see the lines and the structure. So when the sun hits it, you can almost see it here from the light. Yeah. It still has the same kind of structure, the rhythm and the quality.
Yeah.
So why the hell would we flatten it? You might say.
Because it looks more beautiful, right?
And you can do so many things with it, right? No. What we wanted to do, træ, which translate into wood.
Yeah.
It's a high-rise wood building, right?
Yeah.
And we would have loved to make a wood facade.
Yeah.
But because of fire and legislation in Denmark, we're not allowed to do that.
Nope.
So we looked at something we find is just as beautiful, which is the bark. The surface, again, a facade of a tree. It has grooves, it has dents, it has a lot of mistakes actually in it. It's one big scar, full of mistakes and odd things that replicates and connects and creates fantastic surfaces that really are pleasant for our eyes and our feelings. So what if we could do something with that on our steel facade? So it had a kind of an image of how bark would look if it was made out of steel. And we have steel with a lot of mistakes in it and surfaces and scratches and holes. But if we could flatten it as we could here, we could create a groove in the facade so it would differentiate. And these are all different examples on how we could use these flat sheets, which is the dark ones, together with the normal sheets next to it and start to have a facade. What do you mean normal sheet?
The normal sheet is
the normal trapeze sheet.
Ah, okay. So the thing is that the flat sheets become
the groove,
some kind of monochrome tone.
Yes. So it becomes the groove here, and then here you have the normal trapeze, you can say. So each, you can say pattern, or each sheet that you see here is a bark surface, and within them there's this groove. Here the low quality material becomes a high aesthetic material that reflects and try to reassemble or look like kind of a natural surface in a way. A good way of designing with waste is often to come up with a solution where you create a product where you optimize the material you have in hand. So again, form follows availability.
Yeah.
So these sheets are normally super long, but they have bends and they have holes. In the facades for træ, we came up with the idea that maybe we could cut them in smaller pieces and make this shingle system. And one of the reasons why we wanted to do that was because when you look underneath here, you see that there is a wood piece.
Yeah.
And we're actually not allowed to build facades in wood in Denmark when you are above 22 meters.
Because of fire.
But in this case, we then cheated a little bit and made the construction out of wood here.
Yeah.
And so when you look from underneath here, you start to see basically only wood in this facade. So when you're close to the building, it changes identity.
But I see something else. I see like fiberboard. Then I see these metal holders or these montage sheets.
Yeah,
are they also made from this?
C profiles.
Okay. Are they new or?
They're new.
Okay, so these C profiles. Okay, so this was a quick.
This is a quick mock-up to show how you could actually do it, and this is often how we work to represent what would be possible. So these are some of the first mock-ups. And before we built a 80 meters high building with 5,000 square meters of this, we tested out different types of facades.
That would be the way to go.
That would be smart.
That would be smart. I'm just saying. So if you're gonna build a really high building, please test out the facade before. That's what you're saying, right?
Yes.
That's how they do the young ones. When they cut from one thing to another thing,
they TikTok it.
Yeah, exactly.
Obviously, the reason why we do this is because we want to save as much CO2 as possible.
Yeah.
And so the interesting thing here is, can you take a material from a roof and just put it on a new high-rise? If you can do that, you almost don't use any energy at all, so it's super sustainable. We jumped into the life cycle assessment here, which is what we always do. So we calculate the life cycle of the material.
Yeah.
And what is obvious, this is new aluminum.
Yeah, the first one is new aluminum.
Yes.
Yeah.
And the good thing here is that you see we're way down here.
Oh,
so
this
is us using no other material than just taking it down, moving it to the building site where we can mount it.
Okay.
And there we have absolutely no energy use at all. So when we calculate it, very conservatively, it's 90% CO2 saving compared to a new material.
It's a super CO2 reduction in this facade.
Yeah.
And the economy, very quickly.
The economy is very, very good on this. So obviously, most steel materials, when you recycle them, they're calculated as the weight for melting it again. So the price is super low for these materials. And so here for exclusive high-rise, we saved, of course, a lot of money. So in this case, it went the positive way. It was way cheaper, way cheaper to build a building with a direct reuse of aluminum, trapeze and sinus metal facade.
I love the words.
It's so beautiful.
We started looking at facades all over, right?
Yeah.
And you're rethinking facades. And then we took a look at your fantastic, brick and cement mortar issue, which become this very beautiful thing. And then with your studio, we have a problem. We can't do a wood facade, but we have this abundance material, which is abundant. It's has nearly no CO2 emission, and it clearly has a long longevity to it. So the storytelling that you're working with,
architecture communicates, and what is so important now is that sustainability communicates, and that it also tells everyone that goes around in an urban context, sees these sustainable buildings, that you can change behavior, that where materials come from is different. It's not virgin materials from mines or from nature. It's something that we already excavated and has in our urban context that we can transform into beautiful new aesthetics and architecture. And the big question is, what type of aesthetics is it that we're seeing? Because it is a paradigm shift, because the surfaces that we allow scars and mistakes from a previous building to become part of a new aesthetic is very different from what we've done before, where it was a zero mistake culture. All of a sudden we allow it. And we allow it because we can see, just as you're saying, that we save CO2 and we can create beauty out of it. It doesn't have to be a new oak tree or a 300 years old oak tree that we try to build with. It can be something that has almost no value, that we can create matter, beauty, and identity from.
Yeah.
And I think that's so important, and we see it with the brick facade, that it's a problem that becomes a potential, a solution, and a discussion point. The same with the steel, that all of a sudden goes from being useless to being one of the most important facades for metal sheets in the future. And I think that's educating every one of us that works with this, and hopefully also for you guys, inspires you that even though it's just one building, if it reaches you somehow, it starts to grow. And has so much more matter.
One building, 1 million stories.
Exactly.
I was actually nearly moved to tears.
I could
But
see
only
you at
nearly.
times.
Only nearly.
Yeah.
YouTube jump.